So we were discussing projection of planes, right? So planes perpendicular to both planes, and then parallel to one plane and perpendicular to the other plane. We have already discussed. So just for a brief introduction, so this is a plane ABCD. So this is a plane ABCD, and ABCD is inclined to the vertical plane. So it is inclined to the vertical plane at an angle phi, and it is perpendicular to the horizontal plane. So it is perpendicular to the horizontal plane. So to draw that, so these distances and this angle and all this will be given. So first of all, what we do is we draw the horizontal trace, right? So we draw the horizontal trace. So this is the horizontal trace. But then we extend it to meet the vertical plane. To meet the vertical plane. So definitely we have to maintain this angle of inclination of the plane. Then we extend it upward to find out the vertical trace. To find out the vertical trace. So we extend it upward. We extend it upward in this manner. Okay. So length of dimensions of ABCD will be given. So length, height, alright. So this will be given. This will be given. Alright. So at least some values will be given. So we have to work from that. Alright. So suppose the height of the plane. So this height is given. So at that height, alright, we draw one perpendicular. Then we know the edge BC. So we mark the distance BC. So from this point, we draw one perpendicular in this manner. Again, from the horizontal trace, what we do, we project it upwards. So we project it upwards like this and this. So we project it upwards here. And similarly, from the point B up to the intersection line XY, alright, and from there upward to B dash. So here also same, we extend the line upwards. So we get this intersections points. So those intersection points are the points of the projection of the plane ABCD on the vertical plane. So we join them. And we get the front view. So this is the front view. So this is the front view. This is the front view. So this is the front view. And if we see from top, so we will see the edge AB being projected on the horizontal plane, right? So that is the horizontal trace. So if ABCD is extended downward to intersect the plane, horizontal plane, so it will intersect along this line. So that is the trace. So that is also the top view. So here we have the top view. So ABCD is a plane which is inclined to the vertical plane and it is perpendicular to the horizontal plane. So similarly we have this plane ABCD now which is inclined to the horizontal plane now. and it is perpendicular to the vertical plane, and is perpendicular to the vertical plane. So what we do, first of all, we draw the front view. So if we see from the front, we will see the edge AB. We will see the edge AB being projected on the vertical plane here, right, at an angle of theta, which is given. So we draw the edge AB, which happens to be also the vertical trace, because this plane, if it is extended, it will intersect the vertical plane at this line, right? So that happens to be the vertical trace as well. So we draw that, we extend it, to meet the intersection line. We extend it to meet the intersection line here, right? And then from there on, we project it vertically down. So this line over here. Now this distance will be given. So at that distance, what we do, we draw normal to the horizontal trace. But we draw the normal to the horizontal trace. So we draw the normal to the horizontal trace. Then the edge CD will be given. The dimension of the CD will be given. CB will be given. So at that particular length, we again draw this projector here. So this one over here. Then from the vertical trace, we project the point A dash up to A. So we project the point A dash up to A. And similarly, we project the point B dash up to the point B. So we project the point B dash up to the point B. So we get the intersection points here, B, D, C, A, and B. So we get the intersection point D, C, A, and B, which also happens to be the projections of the points A, B, C, D on the horizontal plane. So if we see from the top, now we will see the plane ABCD being projected along this on the horizontal plane. So that is the top view. So this is the top view of the plane ABCD projected on the horizontal plane. So this is the top view. So this is the top view, and this is the front view. So this is the top view. So this we have already done. So an equilateral triangle of side 50 mm has its vertical trace parallel to and 25 mm above XY. So quickly we will just see the concept drawing. All right. So has its vertical trace parallel to and 25 mm above XY again. So 25 mm above XY, and it is parallel to the XY. And it has no horizontal trace. That means the plane is parallel to the horizontal plane. The plane is parallel to horizontal plane. Draw its projection when one of its sides is inclined at 45 degree to the 50. So we have to first draw a line which is inclined at 45 degree to the 50. Right? And then we have to draw the triangle, and then we have to project the triangle onto the horizontal plane. So if you see from top, you will see the triangle here projected at an angle 45 degree, and if you see from the front, you will see the triangle, edge of the triangle projected on the vertical trace here. Alright, so that is the triangle. So we have already drawn this. So here what they have considered the particular distance. So you may consider that as well. So this is the line, suppose. So it is, if I draw a line, so it is 45 degree to this line, okay, and then the triangle will be here, so if now this is the projection of the triangle, so this is the vertical trace, so this is the vertical trace, so this is the vertical trace, and this is the projection of the triangle on the horizontal plane. So this is the projection of the triangle on the horizontal plane. So we have already discussed in the previous class as well, and this is the triangle. So the triangle is parallel to the horizontal plane, and it is at a height 25 mm from the horizontal plane, and therefore we, on the vertical plane, what we see is only the vertical trace. So this trace is what we see in the front view. And if we see from the top, so this is what we will see, the projection of the plane on the horizontal plane. So no horizontal trace. Then we discussed this particular drawing. So we have a square ABCD of 40 mm sides. So square 40 mm sides, and it is 20 mm in front of the VP, and all the sides of the square are equally inclined to the horizontal plane and parallel to the vertical plane. Alright. So it is parallel to the vertical. Draw its projection and show its traces. So definitely, since it is parallel to the vertical plane, so no horizontal trace. Sorry, no vertical trace. Alright. So again, if I consider this one, so has a corner on the HP at 20 mm, sorry. So this is the corner at 20 mm on the HP, and it is equally inclined, all the sides are equally inclined. So there is a square here in this manner, right? So the square stands in front of the vertical plane in this manner. So when we project the square on the horizontal plane, so this is one point projected there on the vertical plane, sorry, and this is the other point projected there, and this is the top point projected there. So this entire square we will see on the vertical plane. So this is the point projected here. Okay, so if we see from the front, so this is X and Y, and we will see the square plane in this manner. If we see from the front, if we see from the top, what we will see is this line projected, this point projected here, this point projected here and this point projected here, and this is the horizontal trace. So that is what we will see at a distance of obviously 20 mm. So at a distance of 20 mm we will see the horizontal trace. So this is what we get. This is the solution. So we have the horizontal trace here and we have the plane projection of the. So this is the point. So this is the point here. And the plane will stand in front of the vertical plane in this manner. And these are the diagonals of the square, right? So if I see from the front, I will see the square being projected on the vertical plane. And if I see from the top, what I will see is the horizontal trace. Now this particular question which we discussed in our previous class, it is actually in the topic of oblique planes, right? So a regular hexagon of 40 mm side has a corner in the HP. So first of all, if I draw the hexagon here, so one point is on the HP. Alright, on the top view of the diagonal through the corner, it is making an angle of 60 degree. Right, so if we first of all consider the hexagon to be on the HP itself, on the horizontal plane, so it will look somewhat like this. Then we can see that we have to make it is inclined at 45 degree to the HP. So from here we have to rotate this line in such a manner that the entire hexagon is lifted up by 45 degrees. So this angle has to be 45 degree. So what is done first of all is that, so the hexagon is first of all considered parallel to both. So the hexagon is considered to be straight. So there is no angle of inclination to the vertical plane. So first of all we consider the hexagon to be on the horizontal plane. Okay. Then what we do, about this edge, the hexagon is lifted. So about that edge the hexagon is lifted about by 45 degree. Now what we do, if you see from top now, so the hexagon is first of all lying on the HP, and then this edge it is lifted up by 45 degrees. So this edge is lifted. So here you will see only the plane of the hexagon being lifted up. Plane of the hexagon being lifted up. So you will see 45 degree lift. So as soon as it is lifted from top, what you will see, the hexagon, it is compressed. It is getting compressed. So what we do, we first of all obtain this projection of the entire hexagon here, alright, and then we lift it up by 45 degree. Then we draw the projectors from the points as we obtained here. So A dash, B dash, C dash is obtained here. So from there we drop the projectors down. We drop the projectors down, and then corresponding to get the corresponding points from this hexagon, what we do is we draw from point F, we project it up to this point, up to F. All right, again from D, it is same, it is lying on the same projector. So ultimately D is projected to this point. So if it is rotated, so we will have to consider D to D, F to F1, D to D1. All right, similarly E to E1. So here E to E1, so we get this intersection point. So from this one we get this two intersection point. All right, then similarly A to A1, C to C1, like B dash to B1 here, right, and B to B1, and we get this intersection points. So now the hexagon is parallel, inclined to the horizontal plane. The hexagon is inclined to the horizontal plane, but it is perpendicular, exactly perpendicular to the vertical plane. All right, so this is what is we get. So we now complete the drawing of the hexagon. So this is the hexagon of which is inclined. One edge is on the HP, one edge is on the HP, and it is making an angle of 45 degree. The plane of the hexagon is making an angle of 45 degree to the horizontal plane. So if you see from the top, this is what you will see. Now what we have to do is we have to rotate it such that the diameter makes an angle of 60 degree. Right, so this figure we have to rotate it such that it makes an angle of 60 degree. Okay, so what we do is we draw the line, we draw the diameter first, right, and then we measure the offsets. So the offsets, then we draw the offsets here, all right, and then we measure the dimensions here, cut the offsets here. Again, from this dimension we measure, we obtain this point. From this point we obtain these 2 points, and ultimately we complete the top view. So this is the top view. Now what about the front view? So as soon as it is rotated, so this as soon as it is rotated, so that the diameter is now 60 degree, right? So in this plane now you will start seeing the some portion of the plane of the hexagon as well, right? So what we do, we drop the projectors from B dash, we drop the projectors in this manner. From A dash we drop the projectors from this manner here, all right, and from C dash we drop the projectors in this manner. Again from A1 we obtain A1 dash, from B1 we obtain B1 dash, all right, then from C1 we obtain C1 dash, all right, and from D1 we obtain D1 dash, and from E we obtain E1 dash. Okay, so A is the point now which is lying on the on the this horizontal plane. Okay, on the horizontal plane. So basically AF is the edge. AF is the edge. Okay, and we have this as the front view. Right, so this is the top view, this is the front view, but this part, this part, this oblique part is not included in your course syllabus, which I have checked. All right, so just for educational purpose and just to understand the concept, so I have explained this as well. So I hope you have understood of what exactly the plane is doing. So initially the plane was, the diagonal was in this manner. Okay, sorry, the diagonal was in this manner. So the hexagon was drawn like this. Okay, so this is the state at this position. Then about this edge, so if I project this point here, so this is what I get, so this is what I get. So then it is rotated by 45 degree. Okay, Then what is done is to make this diameter equal to 60 degree, so it is rotated in this manner. Okay, so you will get a front view as well as a top view, but you need not worry about this because this is not included in your course syllabus. Up to this you need to worry. Okay, up to this you need to worry, up to this portion, up to this portion. So in exam this portion may come. So it may be said that it is inclined to the HP and one of the edge is on the HP and it is inclined at 45 degree to the HP and perpendicular to the VP. So this is the projection. So this plane, the pentagon, I mean the hexagon plane, is perpendicular to the VP at this point up to this point, and it is inclined at 45 degree and it is inclined at 45 degree to the horizontal plane. Okay, so just for your understanding of the projection of planes, how the plane rotates about the axis. Yeah, then in the exam you have to draw this pentagon and this hexagon. All right, so in the last class I told that I will show just some methods of drawing pentagon and some methods of drawing, at least one method of drawing hexagon and I mean pentagon. So this is the simplest method. All right, so first of all, so AB, the edge, all right, the dimension or the length of the edge AB and BP and all this will be given. All right, so the length of the edges of the pentagon will be given. So what we do, first of all, we draw the line AB. So that is the first step. So AB is drawn. Then what we do, we take A as the center and AB as the diameter. Sorry, radius, not diameter, radius. AB as the radius. We draw this circle. So this circle is drawn. Right? A as the center and AB as the radius. Then again B as the center and AB as radius. You draw this circle. Okay. Now once these two circles are drawn, so we will have this point of intersection here, this point of intersection here. So you bisect the line AB. Right? You bisect the line AB. Then at point C, again as the same same radius as AB. All right. With now point C, what we do, we draw this arc. This arc. So once you draw this arc, you get the point E and you get the point F. Okay. And with the bisector, so with the bisector of the line AB, you get the point G. Okay. So what you do, you from E, now you have got the point E. So from E, you draw a line to G and you extend it up to P. Again from F, you draw a line up to G and extend it up to R. Okay, so now you have got the point R and P. So A, B, R and P is obtained. Again now with AB as radius and R as center. So R as center, AB as radius, R as center, you make an arc here. and again ABS radius, PS center. Now you make an arc here, so you get the point Q. So you join the points A, R, Q, P and B to get the pentagon. Right? So I will just repeat the things once again. So first step is AB side, the length of the side AB will be given, so you draw AB. First step. Then ABS radius, AS center, you draw this circle. This circle. Okay, and then BS center, you draw this circle. Now if you join D, now you will get D and C, the points D and C, because these two circles are drawn. So if you join D and C, you will get the bisector of AB. You will get the bisector of AB. Again at point C and ABS radius, we draw this arc. So we get the point E, we get the point F, and we have got the point G with the bisector. Alright, we have already got the point C, so G, now we have got the point G. So from E, you join G and extend it to meet this circle. To meet this circle at this point. From F, you join G. Alright, G is the intersection of this circle at C center and the bisector. Alright, DC. So you join F to G, and from G you extend it to meet this circle, the first circle. Alright, the first circle at R. So now we have the points A, we have the points B, we have the points R and the P. So at RS center and ABS radius, you make an arc here. Again as PS center, ABS radius, you make an arc here. So you get the point Q, and we join A to R to Q to P and to B. So the pentagon is done with side as AB. So AB, whatever it is given, if it is given suppose 6 centimeter, alright, so pentagon will be 6 centimeter. Then in some question it may be given, inscribe the pentagon within a particular circle. Alright, so and the diameter of the circle or the radius of the circle may be given, so we have to inscribe the pentagon within the circle. Alright, so here the edge of the circle is given, edge of the pentagon is given, sorry, and here we are given a circle with a particular diameter or radius, and we have to inscribe the pentagon within the circle. So first of all we draw the circle, then you in the direction that you want. Alright, so suppose you want the pentagon to point in a particular direction, so if you want it suppose in this manner, then you have to orient the diameter in that way. Okay, so that particular diameter has to be in this manner. Alright, so the orientation will depend on what is the direction of the this pentagon. So here once you have drawn the two diameters, the circle and the diameter is drawn, so the first thing that we do is we bisect AO. Alright, we bisect the point AO. So here we see you take some arc, right? Again at O you make the arc here and you bisect. So this is the midpoint of AO. Okay. Now once this is obtained, so once this point B is obtained, now with radius PC, okay, so this is the radius, you make this arc to cut it at this point, right? Q. Okay, so with PS center here, you have made this arc to cut it at Q. Now what we do is we take CQ as the diameter. So now we take CQ as the diameter, right, and we draw this arc. Right, so we have obtained the points E and F. Then, so again with diameter this CQ only, the same diameter. Now what we do, we take ES center, cut at G, FS center, cut at H. Alright, so C is already there, so we join the points. So C to E to G to H and to F and to C. Alright, and we get the pentagon. So I will just quickly repeat the thing. So first of all, what we do, is we the diameter of the diameter or radius of the circle is given, whatever is given, you draw the circle, the first step. So draw the circle, the circle is drawn. All right, then you draw this diameter in whichever direction you want the pentagon to point. All right, so C is the starting point of the pentagon basically. So I draw this diameter and I draw this diameter. Okay, then what I do, so once this is done, so I bisect these two. All right, AO I bisect, then with PCS radius I intersect the diameter at Q. All right, with PS center, PCS radius I intersect this at Q. Then I take CQ as the radius. So CQ is basically the edge, length of the edge of the pentagon. Okay, so once you have CQ, so you draw this arc and this arc. All right, so ultimately you have the point E and F. So once you have the point E and F, again the same radius. Now at E you take the center and you draw the arc at G. Now you shift the center to F. From F you take a center and you mark H as the this intersection here. So we have the point C, E, G, H and F, and we can now draw the pentagon. So we can draw the pentagon. So this is the pentagon joining the points. Okay, so that is another method of drawing the pentagon. Now, how to draw a hexagon? Right, hexagon, it is quite easy. So I have already discussed that in the previous class. Anyway, just in a thorough way, I'm showing. So here you see, so the radius of the hexagon is same as the edge of the hexagon. Right, so that is the basic concept. So what we do, so AB is given. So suppose edge of the this hexagon is given. So you take AB and you first of all draw the circle. All right, first of all draw the circle. Right, this is the first step. Then you draw first of all in what direction you want the hexagon to be drawn. So suppose you want in this one, so A and B, you mark the point A and B. All right, so you mark the point A and B. Then you take A as the center, and whatever is the radius of the circle, you mark the point B and F. All right, similarly you take D as the center and you mark the point C and E. All right, and you join A, B, C, D, E, and F. Okay, so that is a hexagon. So in the hexagon, the edge is equal to the radius of the circle in which the hexagon is inscribed. Right. So AB is given. So you take AB. First of all, draw the circle. The circle is drawn. The first step, you draw the circle. Then you draw the diameter in the direction of the in whichever way you want the hexagon. All right, so you obtain the point A and D. So once A and D is obtained, you take A as the center and the edge length of the edge as the radius. All right, you mark point B and F. Then you shift the center to D. Now with D as the center, you mark point C and E. So you have the point A, B, C, D, E, and F, and you join them, and you join them, and you get the hexagon. Okay, so this is one of the problem which we have again discussed in the previous class. So we have now discussed how to draw the pentagon. All right, so the edge, the pentagon, regular pentagon 25 mm. So this is 25 mm given. So this edge is 25 mm and has one side on the ground. So ground means horizontal plane. So it is on the ground, one of the edges on the ground. So just as the hexagon, so if you now want to tilt it, so you have the projection of the pentagon will also change here. Right? If the diameter or the some edges at a different angle apart from this, right? So here it is given perpendicular to the VP, perpendicular to the VP. So no problem. So it is perpendicular to the VP. So initially we consider the pentagon to be lying on the HP. It is resting on the HP. Entire pentagon is on the HP. So we draw the projectors. Right. So this is the case here. So we have the pentagon lying on the HP, and we have the projectors here. So this is the front view of the pentagon, and this is the top view for the first case. Then what we do, we rotate this up to 45 degree. So the pentagon will get lifted up. So this is rotated to 45 degree. Right. So B dash is rotated to B1 dash. BC1 dash C is rotated to C1 dash. Right. Then what we do, from C1 dash we drop the projectors. From B1 dash we drop the vertical projectors. And from A, obviously it is already on the horizontal plane. Then from C we drop the horizontal projectors to C1, intersect at C1. Similarly, from D we will drop the horizontal projectors at D1, and from B we will drop the horizontal projectors at B1. Okay, so we have these points now. So we have B1, C1 and D1. So that is what will happen when the pentagon is lifted up. The point of the pentagon is lifted up to 45 degree. Right. So when you now see from the top, you will see this projection on the horizontal plane. So this is the projection on the horizontal plane. Okay, another way of doing that is, once you obtain the vertical trace, you shift the vertical trace. So this is parallel to this one, you have shifted it up. All right, so you transfer the points B1 dash to B dash, C1 dash to C dash here. All right, and then you, so this is the second step. All right, so first of all you have rotated the line, so you have shifted that to a point here. All right, then you have dropped the projectors from the points up to the points here, corresponding points here, whatever are the corresponding points. Then from there on, what you do is you drop the vertical projectors down. So from B dash you drop it down. All right, from A dash you drop it down. Now here in while drawing this pentagon, what I did, from C I projected to this point here. Now here what I will do, from C I will project it to this C1 here. So the same point, C1 here or here. This is looking neat. All right, so this is looking neat. It is separated out from the first step. So again D is projected to D1, E is projected to E1. So I get the intersection points basically. So these are the intersection points. Right, then A is projected to A1 and B is projected to B1. So then when I get this intersection points, I join them. So I join them and I get the top view projection. So this is the top view projection. And this is the front view projection, which is also happens to be the vertical trace. But here in this case, if you want to draw the horizontal trace, it will be here on this line. So this, if you project, so this is the line of intersection of this plane. Okay, so that is the horizontal trace here. So this also we have discussed, just a repetition. So draw the projection of a circle of 50 mm diameter having its plane vertical. So first of all, if we consider, so the circle is in a plane of this manner. Right, the circle is in this manner here on this plane, in this plane. Okay, so if you see from, and it is rotated now. Okay, so first of all, having its plane vertical, so its plane is vertical and is inclined at 30 degrees. So this, now we have to rotate it to 30 degree. So about this edge, well, like a dough, we have to rotate it. So what we do is, first of all, we consider the circle to be parallel to the vertical plane and perpendicular to the horizontal plane, right? So parallel to the vertical plane. So it is at 30 mm above the horizontal plane. So this center is 30 mm above the horizontal plane. So it projection will also be 30 mm above the horizontal plane. So this is the point 30 mm above the horizontal plane. All right, and it is at a distance 20 mm in front of EP. So this distance is 20 mm. So this line, basically the vertical, the horizontal trace of the circle will be at a distance 20 mm from the 20 mm from the vertical plane. So at a 20 mm. So first of all, we consider the circle to be parallel to the vertical plane, and therefore the entire circle will be visible. So then we mark important points here and we draw the vertical trace. All right, we draw the vertical trace. So, and through the diameter, and then at some important points here and here and here. So this is the first step. So once this is done, so you get this drawing here. So you have seen that each quadrant is divided into 2 points. Three parts, means 3 parts. Each quadrant is divided. Each quadrant of the circle is divided into 3 parts. Right? So we have this horizontal trace, and this is the front view projection when the circle is parallel to the vertical plane. It is parallel to the vertical plane. Okay, but it is not. It is inclined at 30 degree to the VP. So once we get this, what we do is, here we rotate this, so to a 30 degree angle. So to a 30 degree angle we rotate it. So we will rotate this point, we will rotate this point, we will rotate this point. And similarly we will rotate this point here, we will rotate this point here, and we will rotate this point. Then what we will do, we will shift first of all this line to here, to this line here, where we have shifted the line. Then from, suppose here the third point, we draw the projector to the third point. From the second point we draw the projector to the second point. From the first point we draw the projector to the first point. Similarly from the seventh point here, sixth point here, and fifth point here. So these are all horizontal parallel lines. Okay, kindly remember that these all of these projectors are horizontal and parallel. Okay, so you get these points on this horizontal trace. So once these points are obtained, again from there on you project it up. You project it up. So from here you project it up. All right. So from here again you project it up. So 0, of course 0 will be here. So this is the 0. O, actually O point, that is. So you project it up. Now how to get the ellipse? So from here, now you see it is just rotated as a door. So from here what we do, we have to project the points onto this plane over here. So here from 4 dash I project this line and I get the intersection here. So this is the intersection. Again from 3 dash I project it and I get these 2 points. Again from 2 dash I project it and I get these 2 points. And from 1 dash I project it, I get this 2 points. Again from this point I project it, I get this point and this point. From this point I project it horizontally and I get this intersection point and this intersection point. Similarly at the end point I also get one intersection point here. So I have got all the points. Now only thing remains is we join the points to form the projection. Okay, so one thing you can do is if you have a circular, suppose plate, all right, so you have a plate, so hold it parallel to yourself, all right. So if this is your head and these are your eyes, suppose, so I am seeing from the top, so this is hair and you have the plate in front of you, then you rotate the plate by 30 degree, right? So what you will see is the plate, the diameter here will get reduced, right? So that is what is happening here, right? So if you see from the front, you will see this plate, right? First of, when we consider it to be parallel to the VP, and when we rotate it by 30 degree, so this rotation is done. So here it is rotated by 30 degree. So once it is rotated, all right, so the diameter, horizontal diameter of the, I mean at that point it will get reduced and it will look like an ellipse, right? The projection of that circle, on the vertical plane will be an ellipse. Okay, so this is one particular problem where there is a pentagon. So there is a pentagon and as well as it has a circle inscribed in the pentagon, all right, and the pentagon plate of 45 mm side, so this is 45 mm it is given, so this is 45 mm, has a circular hole of 40 mm, so this is basically a circular hole, so this is basically a circular hole in the pentagon, all right, in the plate of the pentagon, in its center, exactly at the center, all right. The plate stands on one of its edge on the horizontal plane, so the plate is on the horizontal plane at one of its edge, as it was in the previous case, with its plane perpendicular to the VP, all right. So it is perpendicular to the VP as we can see, and 45 degree again we have to incline to the horizontal plane. So first step is to draw the pentagon and the circle. So the first step is to draw the pentagon and the circle. So here what they have done is they have directly taken the dimensions of A1 dash and they have shifted it here with an arc. So they have first drawn a 45 degree line and they have shifted these dimensions A1 dash, A1 dash, A8 dash, A8 dash. Alright, A2 3 dash 7 dash both here. So 3 dash 7 dash both here lies here at this point. So 3 dash 7 dash A 3 dash 7 dash. Again similarly, so here you see C and E both are lying at the same point. So C dash E dash here at the point. So C dash E dash at the point. Okay, so while drawing you have to be very careful so that you do not miss out the points. Which point corresponds to which point. Okay, you have to be very careful. Only then you will get the projection. Of course, obviously, if you are aware of what the projection might look, so in this case, initially, so here the pentagon was lying on the HP, in this case as in the previous case, and with the hole. So it is already lying on the HP. So we have this projection directly here. Right, and then it was rotated by 45 degree with one edge on the horizontal plane. So if you are aware of what it will look like, alright, it should look definitely circle will look like an ellipse, and the pentagon in the length of this dimension here, it will get reduced. Alright. So if you are aware of that, you can make out where the points will lie. So only thing is that you should be, very careful while finding out the corresponding points. So here what they did is, so first thing they did is they made the drawing of this pentagon. So the first thing we make the drawing of the pentagon with AF on the HP. In fact, the entire pentagon on the HP. Alright, and then we inscribe the circle. That is the second step. We inscribe the circle at the center. Then what we do is we project the points B to A and B to A dash B dash here. Alright. So first of all, let us consider the pentagon first. So C and E up to C dash E dash here. Alright. Then D to D dash. So the pentagon is done. Obviously, there is only 3 points of the pentagon. Now the circle here. So 3 and 7, it comes up to this point. Alright. So 2 and 8, it comes up to this point. 4 and 6 comes up to this point, and definitely the 1 and 5, that is the extreme points here and here. Now thing is that we have to rotate it 45 degree, the entire thing. Okay, so that means when I rotate it, this 5 dash point will also rotate in this manner. So from there I will have to project now vertically down. I have to project vertically down now once I have obtained this. So this drawing is similar to this one. So this drawing is basically similar to this one here. So similarly, we find out the various points. All right. So that is what has been done here. So either you can do that here itself and then project it with horizontal projectors. All right. With horizontal projectors, you can project it, or you can take the dimensions of this lens. So A1 dash, A1 dash, then A8 dash, A8 dash. All right. So then we obtain, when we obtain all the various points, so once the points are obtained, in that manner, what we do, so from A dash we project it downwards, and from A we project horizontally up to this point. So we have this intersection point A1, and from B we project horizontally up to this point. So this is B1. So in the similar manner, first of all, let us complete the pentagon. So we have this C and E. So C and E, we have this point. Okay. It's very difficult to make out which one is C and E. Anyway, so this is C and E, so that is what is shown here. So we project it downwards, right? Then from E, obviously it is on the same line, we have obtained the point E1. From C, we have obtained the point, the intersection C1. Similarly, from the point D, project vertically down. So it was rotated up. Okay, so D was somewhere here in this point. So it was rotated 45 degree. And from there, we project it vertically down. Then from this point D, we project the point here. So we have the point A1, B1, C1, D1, and E1. So we join them to form the pentagon first. We join them to form the pentagon first. Then again what we do, again we search for the points in the circle. So 1 is here, so 1 double dash, so we project it down up to this point. So from 1 here we project it up to this point and we get the intersection point. Similarly for the various other points circle, we get, so this point we have, so 7 here, we get the 7 point, and 3 we get the 3 point here. All right, and similarly with the 5 number point, again from 5 we project it up to 5. So similarly for the other points also, 6 1, 8 1, 2 1, 4 1, we get the points, and ultimately we complete the ellipse. Now that means the projection of this circle on the horizontal plane. Okay, so this is the top view now. Okay, so that is the top view. So that is the projection of the this particular metal plate. Okay, so here also the same thing. It is, I mean, when the drawing is inclined to one particular plane and it is perpendicular to the other plane, it is very easy as such, right? Only thing is that when it comes to oblique planes, it becomes a little bit difficult, but oblique planes has been truncated from your syllabus, so no need to worry. So only thing is that this particular points, the corresponding points, you have to be very careful where the points will meet. Okay, so first of all, here also we consider it to be lying on the HP itself. Right? Then along this edge, you hold at this point V and you lift it up. So you lifted it up 45 degree, 40 degree in this case. Okay, in this case it is 40 degree. So the first thing is you obtain the various points. Alright, so different various points you have to obtain, and then you have to, first of all, you project it up vertically up and you get the front view of the initial step. All right, once that is obtained and the dimensions of the various points are obtained, you rotate this up to the required rotation. All right, so here pz dash, pl dash, okay, so all those points you have to mark. Then once it is done, again from those points you have to drop vertical projection down. So that is the third step, vertical projections down. So once these vertical projections are dropped down, again you have to draw the horizontal projections now. Alright, all the horizontal projections now, and you have to find out which point intersects corresponding to which point. Okay, so that is the I mean, it is not very complex. Only thing is that there are so many points. There are chances of getting confused. So you take your time and do the things. Do not hurry. So and you can definitely find out the various points where the points will lie. Okay. So here you see. So PZ was rotated 40 degree and it was, I mean, projected down. So here you see the PZ length E1Z1 is actually, so this is 40 degree. Alright, so it is actually cos of 40 degrees. So this length, alright, P1Z1 is equal to cos this P dash Z dash cos of 40. Okay, so that is why it changes. I mean, there is some decrease in the length. Okay, that is of course mathematical in terms of mathematical terms. I'm just explaining the concept. Okay, through various means. So draw an equilateral triangle. So draw an equilateral triangle.
Projection of planes or PPT kon ketia dibo ekon group.
এইটো দি দিম আজি দি দিম video I'll upload in the YouTube. Video I'll upload in the YouTube.
Okay, okay.
Yeah. So here we have an equilateral triangle of 75 mm side and inscribed a circle in it. Draw the projection of the figure when its plane is vertical. When its plane is vertical and inclined at 30 degree to the VP. So just like this circle over here. So just like this circle over here. So we have the plane. So first of all, we think of the plane. So we have this vertical plane and we have this horizontal plane. Okay, we have this horizontal plane. So now projection of the figure when its plane is vertical. So first of all, we will consider the plane to be vertical. So let us consider the plane to be vertical here. So it is there is no, I mean, distance given from any of the plane. So we will consider one arbitrary distance. So this is the plane. Okay, so let us consider this plane. So we have this plane in front of the VP. So it is given the plane is vertical, all right? So it is vertical and this inclined at 30 degree to the VP. Now what we have to do is we have to rotate it. We have to rotate it such that this rotation is 30 degree, right? So about this axis we have to rotate it like a door, like you are opening a door. No, it is like door opening, and on that door you have to inscribe whatever you have to inscribe. So here it is given, it is an equilateral triangle. One of the sides is inclined at 45 degree to the HP. So 145-degree line we will make on this plane. All right, and we will draw the triangle on that plane here. Okay, on that plane, and then we will rotate it. Okay, so we will start with this one here. First of all here, so we have, suppose, let us draw this XY line. We have the XY line, okay, and at a particular distance we have the horizontal trace. We have the horizontal trace. So we have the horizontal trace. We are not concerned with the dimensions as of now. Okay, we are not concerned with the dimensions. So we have the horizontal trace. Then what I do is, now it is, I mean, it is given, it is at an 45-degree angle. All right, so I draw, suppose I draw one line which is at an angle of 45 degree. Okay, and then I draw the triangle, equilateral triangle. And then we have to draw the circle inscribed in it. All right, so it looks like the Deathly Hallows. Okay, so I think the Deathly Hallows looks like this. Okay, am I correct? Yeah, nobody is replying. Anyway, everybody is asleep. So here again, now we find out the important points. So this is one important point. We project it to the vertical trace. All right, so this is one important point we projected to the vertical trace. Similarly, this is one important point, this is an important point, and all the importance points, whatever there are, we will project it. Okay, so this is an important point. All right, then now when we have obtained this points, various points from the front view of the plane when it was considered to be parallel to the vertical plane, once we have obtained that, now we will rotate the door. All right, so rotate the door. So about this axis we will rotate it 30 degree, all the points. Okay, so now you have to shift the points. So I will draw one line at a 30-degree angle. All right, from here I will drop horizontal projections. All right, and then from this point of intersections I will drop vertical projections. All right, and from here I will drop horizontal projections. Okay, and then you have to draw the front view. Okay, you have to draw the front view, that is left to you. I have already shown every step, so only thing is you have to join the points, corresponding points. All right, and you have to draw the front view. So that is what you require for projection of planes. Okay, so that is what you require for projection of planes. So I am just explaining the things, just a repetition of quick repetition of the things. So just a concept, that is, so initially what you consider is, you consider one door kind of structure. So suppose we have the door here, right? It is at a distance. Okay, so this is the plane on which we have to draw the equilateral triangle and inscribe a circle in it. Okay, then we have to draw one line which is 45 degree to the horizontal plane, right? And we have to draw the equilateral triangle and then the circle. All right, so initially it is all parallel to the vertical plane. Then what we do, so once we obtain all these points, what we do, we have to rotate it up to a 30-degree angle, right? So the entire door is rotated by an angle of 30 degree. So in 3D, that is what it will look like. Okay, so I think we will stop here, and from tomorrow onwards we will move on to solids. Okay, because planes we have covered, whatever you required we have covered.